And last but not least, the creme de la creme of all these examples. This again is something that you're very likely to see on a test or a quiz, because I want to make sure you can find all these different angles inside. So I'm going to give you a tip on this one. Things that I like to do. I like to redraw the angles in the circles separately from the picture and then look at it. So let's put our given information on here. We know that BH is 110 degrees. So BH is a 110 degree arc. And we know that arc DE is a 90 degree arc. And other than that, all we get are some tangents. AC and AG. So let's find angle 1. Here's what I mean by redrawing. Angle 1 is inside the circle. So what I'm going to do is I'm going to redraw the circle over here, and I'm just going to draw angle 1. So angle 1 is created by HD, and it's created by JB. So I'm going to put all that onto my picture. So HD and JB creates angle 1. It's going to be much easier for me to work with this now when I can look at that picture instead of all the other stuff crisscrossing it. What I have to remember is this is circle O. So this point right in the middle of my circle is the center of the circle. So both of these are diameters. So the piece that I have would be HB. From H to B is a 110 degree arc. So if I'm looking for angle 1, I need to find the sum of the two pieces of that circle. So that would be everything from HB and JD. So I need to know what this intercepted arc is and what this intercepted arc is. Well, I have one of them. It's 110. I need to know how far is it from J to D on the big circle. And you might be tempted to think that it's 90, but it's not, because we only have 90 from point D to point E. And I need to know how far it is from point J to point D. So I think I'm going to take some time now and find all the arcs on the circle, because I'm going to need them anyway as I find these different angles. So I noticed that from B to H is 110, but if JB is a diameter, that means all of this is 180. That leaves me 70 degrees left over for arc JH. And I also noticed that HD was a diameter, which means from H all the way around to C is 180 degrees. And I have two pieces there. I have 70 and I have 90. Well, that's a total of 160. That's only going to leave me 20 degrees for this little bitty arc right here. But now I know what that is. So let's finish the rest of this. I've also got HD is a diameter, which means this is 180. So if I've got 110 degrees there, that's going to leave me 70 degrees for this arc over here. So now I've found all the missing arc pieces. Now I should be able to use this to find things in the picture. So let's clear out all this mess, because that just makes it harder to see. And let's start using those arcs to find the parts that are missing. So now that I have all those missing arc pieces, let's go back and find angle 1. So now I know from point J to point D on my circle is 90 degrees plus another 20 degrees for a total of 110 degrees for that arc, because I'm going all the way from point J to point D. So the theorem for angle 1 is going to say add those two arcs of 110 plus the 110 divided by 2, which is going to be 220 divided by 2, which is 110. Now that was a lot of work to find all that, so you're probably thinking, I'm never going to be able to do this. Well, now that we have all the arcs on the circle, it's going to be a lot easier to find the rest of these angles. So I'm going to get rid of that picture that I drew, and we're going to try and find angle 2. So again, what I like to do is draw new pictures and then work with that. So angle 2 is outside the circle. So I'm going to draw the circle. Angle 2 is created by this tangent HA and this tangent AC. Now my picture got shifted a little bit. Yours should be a tangent AC, not going through the middle of the circle like that. So angle 2 is what I'm looking for right down here. And if I follow that picture, what I see is I have a 110-degree arc between point H and point B. And if I follow that out, that's a tangent-tangent angle. So a tangent-tangent angle should always be supplementary to its outside. I'm sorry, a tangent-tangent angle should be supplementary to its smaller intercepted arc. So this has to be 70 to make a total of 180. So angle 2 is simply 70 degrees. And again, I'm going to get rid of that picture and redraw the picture that creates angle 3. So angle 3 is right here. Oops. Angle 3 is right here. So I'm going to draw that using the points. So I'm going to draw a new circle. Angle 3 is created from point E going out to point D, and from E going out to point B. So we're going to D and we're going to B. So angle 3 is an inscribed angle. It's on the circle, so it's going to measure exactly half of its intercepted angle. So I need to know how far it is from point D to point B. Well, that's 70 degrees on my circle, so point E is going to be half of that, which is a 35-degree angle. So angle 3 is 35. Let's get rid of that and find angle 4. Angle 4 is outside the circle over here. So again, let's redraw the circle. It is going from point C through D and E. So E up here, D here, started at C. It's also going through B, which is tangent to the circle. So point B right here. So if I'm looking for angle 4, I need to know those arcs. Between D and B is 70, and I need to know how far is it from E all the way around to B. So from E all the way around to B would be the 20 degrees, the 70 degrees, and the 110 degrees. So that's a total of 200 degrees. So to find angle 4, it's an outside angle, so it's going to be the big arc minus the smaller intercepted arc divided by 2. So as I find angle 4, I'll write that down. It's the big arc of 200 minus the smaller arc of 70 divided by 2, which is 130 divided by 2, which is 65 degrees. I promise this gets easier the more you work with it. Angle 5. Angle 5, again, is inside the circle right here. So let's draw the circle. We draw the circle. Angle 5 is created by segment E to B. So from E to B, and from H to D. So from H to D, and angle 5 is this angle right here. So I need to know how far it is from arc B to D. That's 70. And I need to know how far is it from arc H to E, which is 70 and 20 for a total of 90. So now I'm going to add these two arcs together because since it's an inside angle, angle 5 is going to be that 90-degree arc plus the 70-degree arc divided by 2, which is 160 divided by 2. So that's an 80-degree angle for angle 5. Let's get rid of that. Draw ourselves a new picture. Angle 6, right down here. Let's draw the circle. Angle 6 is created by point G to B and from H to B. So from J to B to H. This is angle 6. So what I need to know is what is the arc from H to J, because that's what's being intercepted by this angle 6. Well, in my picture I can see from H to J is 70 degrees. So if this is a 70-degree arc, angle 6 has to be exactly half, which is 35. Angle 7. Angle 7 is outside the circle right here. So let's see how that's created. Again, let's redraw the circle. Angle 7 starts at point F, goes through J, down to B. So let's put those on there before we forget. So we started at F, went through J, and all the way through point B. And then we also went through point E, through D, all the way out to C. So it was from point F, we went through E, and then all the way out to point D. So this one's going to be an outside angle, which is half the difference of the big arc and the small arc. So I need to know what is the length from point J to E. Well, that's 20 degrees. And from B to D is 70 degrees. So to find the measure of angle 7, I have to do the difference of those two. So it's going to be the big arc of 70 minus the smaller arc of 20 divided by 2. So that's going to be 50 divided by 2, which is 25. Angle 8. Angle 8 is over here. It's on the circle. So let's draw the circle. It starts at point B and goes out, and then it goes from point B up through point H. So this is point H, this is point B, point A is out here somewhere. So this is on the circle. So what I need to know is what is the arc from H all the way around to B? And from H to B is 110. So since angle 8 is on the circle, that means angle 8 is going to be half of that 110, which is 55. And then finally we've made it all the way back to angle 9. So let's find our last one. Angle 9 is outside the circle up here. So let's redraw that circle. It starts out at point G and hits point H. And then it goes through the circle at point J down through point B. So we started at point G, we hit tangent to the circle at H, we went through point J all the way down through point B. And I hope what you're noticing is when you redraw these pictures, it's much easier to see what you're working with. This is an angle outside the circle, so I'm going to take the big arc HB minus the small arc of HJ divided by 2 to find that angle. So I need to know those numbers. From H to B is 110, and from H to J is 70. So this means that my angle is going to be the 110 big arc minus the 70 small arc divided by 2, which is 40 divided by 2. That's a 20-degree angle. And I know it's a lot of work, but you can handle it, you can do it. Good luck on the worksheet, and please, please, please see me if you have any questions or you are struggling to do this.